A termite mound in Africa stays cool in 100-degree heat, with no air conditioning, no electricity, no moving parts. A shark swims through water that's almost bacteria-free, not because of chemicals, but because of the microscopic texture of its skin. A lotus leaf never gets dirty. Rain doesn't wash it clean. It simply never lets dirt stick in the first place. None of this is science fiction. It's biology. And nature didn't just stumble onto these designs. It tested them, failed, adjusted, and perfected them over millions of years. Here's the strange part. Most of our modern engineering ignores all of it. But a small, fast-growing group of professionals is changing that. They're not inventing from scratch. They're going back to the original engineer, nature itself, and translating its answers into the built world. This job is called bio-inspired design. Hi, and welcome to Mnemosis, your career intelligence podcast. Here, we explore the jobs of tomorrow, their real-world impact, future demand, and where the global job market is heading next. Let's dive in. A bio-inspired designer studies how living systems solve problems, then translates those solutions into technology, architecture, and products. Not decoration, not nature-themed design, function. They ask, how does a beetle harvest water from fog? How does a bird's wing reduce drag? How does a slime mold find the most efficient path between 2 points? Then they apply the answer to real-world engineering. Buildings that regulate their own temperature, materials that self-heal, transport systems that use less energy. This role sits at the intersection of biology, engineering, and design. It's part scientist, part inventor, part translator between two worlds that rarely speak to each other. This career doesn't have one fixed entry point, which is part of its appeal. Talking about education, common backgrounds include biology, industrial design, architecture, materials science, or biomimetics, a growing academic field with dedicated master's programs. Core knowledge is centered around an understanding of natural systems and evolutionary problem solving, familiarity with materials science and structural engineering, and basic sustainability and systems thinking. Key skills include cross-disciplinary thinking. You need to speak both biology and engineering fluently, strong visual and conceptual communication, prototyping ability, whether physical or digital, comfort with ambiguity. Nature doesn't hand you a spec sheet. In terms of experience, many enter through design studios, sustainability labs, R&D departments, or academic research before moving into applied roles. No single degree defines this path. What defines it is the ability to observe nature like a textbook and translate it like an engineer. Let's talk outputs, the tangible things this job produces. Building facades that cool themselves without electricity, inspired by termite mounds. Adhesives that stick and release infinitely, modeled after gecko feet. Wind turbine blades redesigned using whale fin geometry. Quieter, more efficient. Water filtration systems inspired by mangrove roots. Packaging materials that biodegrade like mushroom structures. Robotic movement systems modeled on insect locomotion. These aren't concepts. They're patented products, built structures, and functioning systems already used in cities, factories, and consumer goods today. We're entering an era where old design methods are hitting their limits. Materials are running out. Energy costs are rising. Climate pressure is forcing every industry, architecture, transport, manufacturing, to rethink how things are built. Nature has already run over 3.5 billion years of research and development. It's tested every design against real-world failure. What survived is optimized. Bio-inspired design isn't a trend. It's a response to a resource-constrained future, using efficiency patterns that already work instead of reinventing them from zero. As industries shift towards sustainability by necessity, not choice, this role moves from niche to essential. This field is still emerging, but it's no longer experimental. Architecture and engineering firms are hiring biomimicry consultants for major sustainable builds. Automotive and aerospace companies use bio-inspired design to cut drag and weight. Materials science labs in both corporate R&D and universities are actively researching bio-based alternatives to plastics and synthetics. Government-funded sustainability and climate tech initiatives are increasingly funding biomimicry research. Organizations like the Biomimicry Institute and design-forward companies in construction, consumer goods, and clean energy are actively building teams around this expertise. It's not mainstream yet. That's exactly why early movers have an advantage. This role is for people who notice patterns before they notice problems. If you've ever looked at something in nature and thought, "Why does this work so well?" That instinct matters here. This is for people who like combining fields instead of picking one. Biologists who wish they could build things. Designers who wish they understood systems more deeply. Engineers who want their work to feel less mechanical and more alive. It's not for people who want rigid, predictable processes. Nature is messy. So is this job. But if you're drawn to solving big problems by looking somewhere unexpected, this could be your next chapter. If you're looking for a real hack to the future, then visit Mnemosis.com. Learn more about this role and build your tomorrow by taking action today.